Hi, this lesson is about the trigonometry of right triangles. So first let's talk about triangles in general. So a triangle is a three-sided shape where the sum of the measurement of all of the angles is 180 degrees and could also be expressed in radians as pi radians. So there are different types of triangles. There's a scaling triangle, which means none of the sides are equal, as well as none of the angles. Isosceles triangle, which means two sides are equal and the two base angles are also equal. And the base angles are the angles opposite of the equal sides. An equilateral triangle means all three sides and all three angles are equal. And because the sum of all the angles is 180, that means the angles would equal 60 degrees each, since they're equal. And then we have a right triangle, which means that one of the angles must be 90 degrees. Remember, 90 degrees can also be stated as pi over 2 radians. The side opposite of the 90-degree angle is called the hypotenuse, and the other two sides of a right triangle are called the legs. So the altitude or the height of a triangle is a line segment drawn from a vertex on the triangle that is perpendicular to the opposite side. Remember, perpendicular means that it creates a 90-degree angle. So with right triangles, because there's already a 90-degree angle, the altitude will be one of the legs. But for other triangles, you would have to create that height, draw it perpendicular to the side opposite of it, which is called the base. So the area is measured by taking 1/2 of the base times the height. All right, so let's compute some information here regarding a triangle. So we want to find the perimeter and the area of the following isosceles triangle. Remember, isosceles means that two of the sides are equal and therefore the two base angles are also equal. So these are the two equal sides and the base angles are opposite those sides. So B and C are the equal base angles. Okay, but to compute the perimeter, we just need to add up all of the sides. So my sides are 5, 5, and 4. So add those up and you get the perimeter is 14 centimeters. The area is 1/2 base times height. So the height is given here to be root 21. Your base is 4 centimeters, so that's the side here. So 1/2 times 4 times root 21 gives us 2 root 21. And here the units are centimeters squared because you computed area. So with right triangles, you have a theorem called the Pythagorean Theorem that's based off of the three legs of the triangle, the two legs and the hypotenuse. So if we have a right triangle with legs A and B, and let C be the hypotenuse, then the Pythagorean theorem says that the hypotenuse squared is equal to one leg squared plus the other leg squared. So C squared equals A squared plus B squared. So let's find the hypotenuse in this right triangle with legs equal to 2 and the other one equal to 3. So here's a picture of what it is we want to compute. We want to compute the hypotenuse that I'm going to call C. So using the Pythagorean theorem, I have C squared equals 2 squared plus 3 squared. So the right side becomes 13. But when you take the square root, remember you're solving for the length of the hypotenuse. So you only want the positive answer. You wouldn't put plus or minus the way we often do when you're solving equations like this. It's just root 13. All right, so what are similar triangles? Similar triangles are triangles with the following attributes. So similar triangles will have corresponding angles that are equal and corresponding sides that are proportional. A proportion is basically one fraction equal to another. So if I look at these two, these are two similar triangles. So you can see that they have the same exact shape, like basically the green one would fit nicely into the blue one. It's just a little smaller. And this notation that you see here, this line here by a sub 1, angle a sub 1, is the same that it looks like in the other triangle. That means a sub 1 and a sub 2 are equal angles. And the same thing occurs here with b sub 1 and b sub 2. There we put two curved lines. So b sub 1 and b sub 2 are equal. And then again, the c's, the c sub 1, we use 3 to indicate that, 3 curves. C sub 1 and C sub 2 are equal. So that's the first thing that must be true about similar triangles, is that corresponding angles from one triangle to the other must be equal. Okay, this notation here, triangle A sub 1, B sub 1, C sub 1, is similar to, this symbol is read as is similar to, triangle A sub 2, B sub 2, C sub 2. Okay, so the corresponding angles are equal, but now we have to talk about the sides. The sides need to be proportional. All right, so the first set of proportions that we set up here are showing you that a sub 1 corresponds to a sub 2 because a sub 1 and a sub 2 are opposite of angle a sub 1 and angle a sub 2, which we have already established are equal. But the same is true for b sub 1 and b sub 2. So that first proportion indicates that those two proportions are equal. And the same is true for all the other relationships. A sub 1 to a sub 2 equals c sub 1 to c sub 2. And then finally, b sub 1 to b sub 2 equals c sub 1 to c sub 2. Okay, but you can also look at it from the perspective of on the same triangle. So, for example, here, this proportion, a sub 1 is to b sub 1 as a sub 2 is to b sub 2. So either way, whether you're looking at it from this perspective or the one below, if you cross multiply your proportion, you would still get the same result. You would get the same product in either case. So you can set up your proportions any way you want. As long as you've established that the angles are equal, then you would set up the proportion according to corresponding sides. All right, so here's an example of similar triangles. I have triangle here, FLO, and triangle HIT. So angle F equals angle H. So I'll use the same notation that I used above. Angle L equals angle I. So I'll put two curves here. And angle O equals angle T. So I'll do 3 to indicate that. Okay, so what are my corresponding, my sides? So 15 is to 30, as 20 is to 40, as 25 is to 50. And notice that if you were to reduce every single one of these, they all just equal the same ratio, which is 1/2. So every side has a ratio of 1 to 2 between the similar triangles. So to solve a triangle, we're going to be working with right triangles. And what that means is when you have a right triangle, that means you have one that's 90 degrees and the other two are acute complementary angles. So acute means less than 90. Complementary means that when you add them, they equal 90. So if these two acute angles add up to 90 and this one is 90, the total is 180 as we expect. So when you're solving a right triangle, that means you're trying to find out what the sides are and what the angles are. For notation purposes, we're going to be using capital letters A, B, C to indicate the angles, where A and B will be the acute angles and C will be the right angle. So like what you see here, here's my right angle, here's acute angle A, acute angle B. Then we're going to use lowercase letters to identify the sides. So little a, little b, little c, and the side goes opposite of the corresponding angle. So opposite of angle A is side A. Opposite of angle B is side B. And then side C will always be your hypotenuse because it's opposite of the right angle C. Okay, so that's how you should be drawing your triangles, right triangles. So now we get into trigonometric functions. So trigonometric functions are defined based on relationships between the angle of a triangle and the ratio of two sides of a right triangle. So our trigonometric functions will be based off of right triangles. We're going to let x represent the horizontal distance of the right triangle, and y represent the vertical distance. And we're going to let our hypotenuse be called r. Okay, so it'll make more sense in the next chapter why we call it r instead of c, but r is the hypotenuse of the right triangle. Then you can define your six trigonometric functions in terms of a ratio of 2 of the sides. So before I talk about this, we're going to be referring to this picture here. So here's my right triangle. The angle I'm going to call theta. The horizontal side is called x. The vertical side is called y. So those are your legs, x and y, and my hypotenuse is called r. So based on the Pythagorean Theorem, you know that this is true. And we're going to now define our 6 trigonometric functions. So the first one is called sine. And sine is abbreviated like this. So sine of theta, so it'll always be the trigonometric function of an angle, is equal to y over r. So it's equal to the side opposite of theta and the hypotenuse. So that's your ratio. Cosine of theta, which is abbreviated as cos of theta, is equal to the adjacent side to theta over the hypotenuse. So it's x over r. Then your tangent of theta, this is abbreviated as tan theta, is equal to the opposite side of the angle divided by the adjacent side to the angle. So it's y over x. Okay, so those are the 3 main trigonometric functions. So those are the ones that we use most often. But there are 3 others, and those 3 others have a relationship with the first 3. So the first one is cosecant of theta. Cosecant is hypotenuse r over y. Notice that sine and cosecant are reciprocals of each other. So if sine is y over r, cosecant is r over y. You just flip these two. So similar relationship between cosine and secant. Secant is abbreviated like this, secant theta of r over x. So secant is the reciprocal of cosine. Cosine is x over r. Secant is r over x, the hypotenuse over the adjacent side. And the last one is cotangent. Cotangent and tangent have a relationship because cotangent, abbreviated COT of theta, is the reciprocal of tangent. So it's the x over y, it's adjacent over the opposite side. So tangent and cotangent do not use the hypotenuse. They only use the legs. Sine and cosine use one of the legs as well as the hypotenuse. Okay, so as I was mentioning, you would say in this picture, x is adjacent to the angle theta, y is opposite of the angle theta, and r is the hypotenuse of the triangle. So instead of memorizing this, which may be a little hard, this is kind of just a little shortcut to help you memorize. This is read as Sohcahtoa, and it's just a quick way to remember what the relationships are with the sides. And so these letters mean something. So S stands for sine, And S is opposite over hypotenuse. That's what the O and the H represent. And so opposite over hypotenuse is Y over R, which is exactly what we stated above. So it might be easier to remember opposite over hypotenuse instead of Y over R. And then the next one, the cup part, that stands for cosine equals adjacent over hypotenuse. So the side next to the angle and the hypotenuse, that's x over r. And the last one, TOA, that means tangent equals opposite over adjacent. That's where the O and the A represent opposite over adjacent. So that's opposite over adjacent, which is exactly what we saw above. Okay, so this is just a trick to help you memorize these. Okay, but memorization will be required because you do use these trigonometric relationships between the angle and the sides often throughout this course. So as I mentioned before, some of our trig functions are reciprocals of the other. So sine of theta is the reciprocal of cosecant, and therefore cosecant of theta is the reciprocal of sine. The same is true for cosine and secant. Cosine of theta is the reciprocal of secant, therefore secant of theta is the reciprocal of cosine. And then the last reciprocal relationship is tangent of theta is the reciprocal of cotangent, and therefore cotangent of theta is the reciprocal of tangent. But there is an additional relationship for tangent. Tangent is sine of theta divided by cosine of theta. And since tangent and cotangent are reciprocals, cotangent is equal to the reciprocal of this fraction, which is cosine of theta over sine of theta. So all of this information is needed not only to understand how to identify your 6 trigonometric functions based off of a triangle, but also later on in the course to simplify trigonometric expressions, it is necessary to know these relationships. Okay. So suppose you are given a point on the terminal side of an angle. Remember, the terminal side is where the angle stops rotating. The initial side is where it starts, and we typically start in the positive x-axis. So we can use the Pythagorean Theorem to help us determine the value of r. And remember what r is. It is your hypotenuse. So here we have find the values of the trigonometric functions of the angle in standard position whose terminal side passes through the point 6, 5. So here's my triangle. This is the angle that's created by the terminal side, which starts at the x-axis and ends, with the initial side that starts on the x-axis and the terminal side that goes through this point right here, 6, 5. All right, so in order for me to identify the 6 trigonometric functions, I need to know the 3 sides of the triangle. So this one is 6 units, this one is 5 units, but in order to figure out the hypotenuse, I called it C in this problem, but C or R, however you want to call it, it is the hypotenuse. So use the Pythagorean Theorem and take the square root of both sides, so you get that C is root 61. Okay, so remember now the Sohcahtoa. Sine is opposite over hypotenuse. So opposite of theta is 5, hypotenuse is root 61. Cosine, which is the ka, remember Sohcahtoa, cosine is adjacent over hypotenuse. What's adjacent to the angle? Well, that's 6. Hypotenuse is root 61. Tangent, that's TOA, is opposite over adjacent. So what's opposite of theta? 5. What's adjacent to theta? 6. So it's 5, 6. Okay, now we'll do the other three. And remember, the other three have relationships. The reciprocal of tangent is cotangent, so that's just 6 over 5. The reciprocal of sine is cosecant, so that's root 61 over 5. And the reciprocal of cosine is secant of theta, so that's root 61 over 6. Okay, so in the case of these two, it is possible to rationalize them. So when you're doing homework for this, make sure you follow the directions. Rationalizing means that you get rid of the radical in the denominator. And the way you do that is you multiply the numerator and denominator by the same radical. So that just gives us 5 root 61 over 61. And you would do something similar with cosine. You would multiply top and bottom by root 61. So you would get cosine is 6 root 61 over 61. Okay, so sine and cosine could be expressed differently. So here's another example. Find the values of the trigonometric functions of the angle in standard position whose terminal side it goes through 5, 12. So just like the last example, I have to figure out what my hypotenuse is. 5 and 12 are the lengths of the adjacent and opposite legs. So this would be adjacent because that's the movement along the x-axis. And this would be the value for the opposite leg. So you plug that into Pythagorean Theorem. This time your hypotenuse works out to be a whole number. It's 13. So remember, this is the hypotenuse. So if I know the adjacent side, the opposite side, and the hypotenuse, I can definitely answer all 6 trig functions. Sine is opposite over hypotenuse, so that's 12 over 13. Cosine is adjacent over hypotenuse, so that's 5 over 13. Tangent is opposite over adjacent, so that's just these two. It's 12 over 5. The rest are just reciprocals. Reciprocal of sine is cosecant, that's 13 over 12. Reciprocal of cosine is secant, that's 13 over 5. Reciprocal of tangent is cotangent, so that is, this is a typo, so that is 5 over 12. Okay, so that's how you find your 6 trig functions, when you know a point that the terminal side goes through. All right, so if given the value of a trigonometric function, you can determine 2 sides of the triangle and then use the Pythagorean theorem to find the third side. So, so this is more of the same but different information given. So suppose sine of theta equals a half. We want to find cosine of theta and cosecant of theta. All right, so if sine of theta is a half, remember sine is opposite over hypotenuse. So here's my picture. Opposite of theta, here's your opposite, and here's your hypotenuse. I need to figure out what my adjacent side is so that I can answer the question regarding cosine. Cosine is adjacent over hypotenuse. I don't know what the adjacent side is. So use the Pythagorean theorem. So I get 2 squared equals 1 squared plus b squared. So I called it b or x or whatever you want to call it, or a for adjacent. It doesn't matter, but you're trying to find this side right here. So when you solve it, you get that b is root 3. So now that I know that b is root 3, I get that cosine is adjacent over hypotenuse. That's root 3 over 2. And cosecant is the reciprocal of sine. So cosecant is 2 over 1, which is just 2. Okay, let's do another example. Similar to that, suppose you're given that secant of theta is root 5 over 2, and we want to find tangent and cosine. So remember, secant is the reciprocal of cosine. So if you just do cosine right away, you'll get it's 2 over root 5. And if you were to rationalize it, multiply both sides by root 5, you get 2 root 5 over 2. All right, so remember that means that 2 is the adjacent side and root 5 is the hypotenuse. So I need to know what the opposite side is because tangent is opposite over adjacent. That's the TOA part of that shortcut that I gave you. So I have to solve for what that other side is. So here I am solving for that side. Use a Pythagorean theorem. So I have root 5 squared equals 2 squared plus b squared. So when you solve that, you get that b is equal to 1. So now I know that b is equal to 1. And so that's your opposite side. This is the opposite side. And so tangent is opposite over adjacent. So that is 1 over 2. Okay, so it could be thought through logically using your Sohcahtoa. You could draw pictures. So whatever makes more sense to you, the student. So given a right triangle with a leg equal to root 2 and a hypotenuse equal to 2, find all 6 of the trigonometric functions. All right, so you're told what the hypotenuse is, and you're told that one of the legs is root 2. So when you solve this, you get that A, the other leg, is also root 2, which basically means you have 2 legs with the same value, which means it's isosceles. Nevertheless, it is still a right triangle, so all the relationships still exist. So sine is opposite over hypotenuse. Now, we don't really know which one is opposite, but we know that they're the same, so it doesn't really matter. The leg is root 2, so it's root 2 over 2, which is the hypotenuse. Cosine is also adjacent over hypotenuse, but both legs are root 2, so it's still root 2 over 2. Your tangent is opposite over adjacent. Again, the 2 legs are equal, so it's root 2 over root 2. So tangent is just 1. Your cosecant is the reciprocal of sine, so it's 2 over root 2. But when you rationalize it, you get 2 root 2 over 2. These 2's cancel, and you get that cosecant is just root 2. Same thing occurs with secant because it is the reciprocal of cosine. And when you rationalize it, you again get root 2. And the reciprocal of tangent is cotangent, but the reciprocal of 1 is just 1. So we get a lot of the same answers when you have an isosceles right triangle. Okay, so sometimes you do need a calculator to evaluate a trigonometric function. And you have to make sure that your mode is set appropriately to either degrees or radians, depending on what you're trying to evaluate. So we're going to use a calculator to find the values of the following trigonometric functions. We're going to round to 5 decimal places. All right, so first few, you need to be in degree mode. So sine of 25 degrees gives you 0.42262. Cosine of 115 degrees gives you negative 0.42262. Tangent of 220.5 gives you 0.85408. And then we go on to cosecant. Now, once you get to cosecant or secant or cotangent, your calculator doesn't have those trig functions. The majority of all calculators would only have these first 3. So you have to convert cosecant to something that you do know, which is sine. The reciprocal of cosecant is sine. So then you enter 1 divided by the sine of 280.04 degrees, and you get negative 1.01555. So now we are in radian mode with these. So you have to switch your mode to radians. So we have the sine of pi over 9, and you get 0.3 34202. Make sure you use pi. There should be a key for that in your calculator and not 3.14. You don't want to round prematurely. Same thing here. Take the cosine of 2 pi divided by 9 and you get 0.76604. And then I need to take the cotangent of negative pi over 5. Cotangent is also one that's not in your calculator. So the first thing you have to do is write it in terms of something you do know. And cotangent and tangent are reciprocals. So you'd have to enter 1 divided by the tangent of negative pi over 5. Make sure you use the negative symbol and not the minus symbol. They are not the same. This is a negative. And you get negative 1.37638. All right, so we have some special triangles that you should make an effort to memorize. So as I mentioned before, when you're solving a triangle, it means to find all 3 sides and all 3 angles. We know that the sum of the 3 angles is 180. We know the definitions of the 6 trigonometric functions. We just talked about that. And we know the Pythagorean Theorem. And so combination of all this information allows us to solve right triangles. But there's 2 in particular that you should memorize. One is the 30, 60, 90 triangle, and the other one is 45, 45, 90 degree triangle. So when you have a 30, 60, 90, no matter what x is, if the side opposite of 30 is x, then the side opposite of 60 will be x times root 3, and the hypotenuse will be twice x. So even if x is 5 or 100 or 1,000, this proportion will still exist. The other one, the 45, 45 degree and 90 degree triangle, this is an isosceles triangle. And as I mentioned a few minutes ago with isosceles triangles, your legs are equal. So if one is x, the other one is also x. And that means that the hypotenuse, the relationship between those, will be x root 2. So when solving a right triangle, we want to solve a right triangle, and that means we need to find out angle ABC and as well as all of your sides. All right, so you're given that the right triangle has A equal to 30 degrees, which means we're going to be referring to this because if one acute angle is 30, the other one must be 60. And we're going to let x equal 5. So that's this value here. That's equal to 5. So if x is equal to 5, well, first here are my angles, 30, 60, 90. If x is equal to 5, then the other side, x root 3, will be 5 root 3. And the hypotenuse will be 2 times x, which is 10. So the 3 sides are 5, 5 root 3, and 10. And that means the triangle is solved. If we move on to a 45, 45, 90 degree triangle, so x is the side opposite of 45 degrees, and x root 2 is opposite of the hypotenuse. So we want to solve the right triangle given that b is equal to 45 degrees and x is equal to 3. So if b is 45 degrees, that means a is also 45 degrees, and your c is always your 90 degree angle with right triangles. So when x is equal to 3, then the hypotenuse would be x root 2, which is 3 root 2. So each side is 3 units and the hypotenuse is 3 root 2. All right, so here we're switching to radians, but again, we can do this without a calculator. These are special angles because pi over 6 is 30 degrees. The next one that uses pi over 4, that's 45 degrees. And the third one that uses pi over 3, well, that's 60 degrees. So it's one of the triangles above. So the sine of pi over 6, which is the sine of 30 degrees, if I could just look back here, the sine of 30 degrees is opposite over hypotenuse. So if I put that in, opposite over hypotenuse, that means the sine of 30 degrees is equal to a half. With pi over 4, that's a 45-degree angle. Remember, there the sides were x and the hypotenuse was x root 2. Again, canceling your x's, you get 1 over root 2. Rationalizing, you get root 2 over 2. And rationalizing again means multiplying this by root 2 over root 2. So things simplify. And then tangent of 30 degrees, well, 30 degrees is 60. Tangent is opposite over adjacent. So again, if I could just look back here. So I'm at 60 degrees right here, opposite over, opposite, okay, sorry about that. Opposite over adjacent. So it's x root 3 over x. So we'll see that in the next line here, x root 3 over x, the x's cancel, and so the tangent of pi over 3, or 60 degrees, is root 3. So when you have a 30, 60, 90 triangle or a 45, 45, 90 degree triangle, you can solve your trigonometric functions without the use of a calculator. So in order to get the answers quickly and easily, notice in all of these examples, the x's canceled out. It would just be easier for you to memorize these two triangles. So the one in purple is the 30, 60, 90 degree triangle. So opposite of 30 is 1, opposite of 60 is root 3, and the hypotenuse is 2. Once you know those three sides, you can figure out all 6 of the trig functions for either 30 degrees or 60 degrees. And the 45, 45, 90 degree triangle has 2 equal sides, root 2 and root 2, and the hypotenuse is also 2. So you can answer you can evaluate all 6 trigonometric functions for 45 degrees. And as a reminder, all of your angles could be expressed as radians, and since these angles are really common, it would be helpful for you to memorize what the radian measure is as well. 30 degrees is pi over 6, 60 degrees is pi over 3, 45 degrees is pi over 4, and 90 degrees is pi over 2. Okay, so that's it for this lesson. Give the homework a try. Good luck.